Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to talk about the ionization process of polyprotic acids. Now, I know polyprotic seems like a big word, but all it means is that there's more than one proton. And the two acids that we're going to look at are sulfuric acid that has 2 protons, and we have phosphoric acid that has 3 protons. So once again, the word polyprotic just means many protons, okay? And the way that they donate their protons, because they're both acids, it might be a little bit different than what you think, okay? For example, let's start out with the phosphoric acid. One thing that we know about the phosphoric acid is that it's not on our list of strong acids, so it's going to be a weak acid. So we are going to end up using equilibrium arrows to show the ionization process, or the splitting up into the ions. That's basically what ionization process means, okay? Now, the thing is, a lot of students think that it's going to happen in a single step, and that's not true. It's going to happen what we call stepwise, meaning that we're going to pull off one proton at a time. So I'm going to pull off one proton, so there it is, okay? And if we remove one proton from this substance, what's remaining is going to be H2PO4, and it now has a negative charge because we removed one of its protons that has the positive charge, okay? Now, we're going to take this substance and put it down here as H2PO4 with the negative charge, and then we're going to take off the second proton. So we're going to take another proton off, and if we take a proton off of this substance, what's remaining is just HPO4, and since we took off another proton, okay, it's now going to have a -2 charge, and then we're going to repeat that process one more time. We're going to put HPO4 down here with the -2 charge, and we're going to take off the third remaining proton, okay, and that's going to leave us with something that looks like this. So it happens in steps. Not all 3 protons come off at one time, okay? Now, since we have 3 different equilibriums here, we're going to have 3 different equilibrium constants. The first one's going to be called Ka1. Remember, K stands for the equilibrium constant. A means it's an acid, and the 1 means the first proton, okay? Which would make this Ka2, okay? And this is going to be Ka3, okay? So that's kind of how it works with polyprotic acids. Now, how this one's different is that this is a strong acid. It is on our list of strong acids. And if it's a strong acid, okay, that first proton is going to come off 100%, okay? So the first step is not going to have an equilibrium arrow. It's going to have a single arrow, but remember, that strong acid is only going to be for the first proton. So the first proton comes off, and we have something that looks like this, okay? And then we're going to take this down. We're going to do the same thing that we did before. So here's the HSO4. That's a negative, okay? Now, this is not on my list of strong acids. This is going to be considered a weak acid, just like this was a weak acid, and this was a weak acid, and this is a weak acid. And if it's weak, it will not get the single arrow. It will get the equilibrium arrow. And we'll pull off the second proton, and it'll look something like this. So the main idea here is that when you have a polyprotic acid, an acid with more than one proton, the protons are going to come off in steps, okay? Sometimes they're strong, sometimes they're weak. And so that's kind of like what makes sulfuric acid kind of special. In our case of all the other strong acids, there's only one proton. Sulfuric acid's the only one that's polyprotic. If you found this information helpful, please give it a like and subscribe. When you add that comment, it really does push this information to other students that are interested in learning chemistry.